most of the time when we're adding and subtracting fractions, they do not have the same denominator. And we need to find an LCD and then build up both fractions to have the same denominator. So that's kind of how most of the questions are in this section. So when adding fractions with different denominators, we need an LCD, or the lowest common denominator. So if you had 1 over 2 plus 6 over 8, the LCD of these two fractions is 8. So we would need to multiply the first fraction by a 4 over 4 to get the same denominator. You wouldn't multiply the second fraction by anything because it already has the LCD. So that would change the 1/2 into a 4 over 8. And then now that they have the same denominator, you would just add them to get 10 over 8. And then you would want to simplify this to get 5 over 4. So this is kind of the framework for adding and subtracting rational expressions where you need to get an LCD. So the process for getting an LCD, you want to first factor each denominator completely. Then the LCD is a product containing each different factor. And if a factor occurs more than once in any one denominator, the LCD will contain that factor repeated the greatest number of times that it occurs in any one denominator. So let's look at some examples. The LCD between 4 and 8 is 8. Looking at the x's, I have an x squared and I have an x. So I have 2 x's in the first one and only 1 x in the second one. So for the LCD, it's the greatest number of times that you see it in any one denominator. So because I see it 2 times in the first one, I need to have 2 in my LCD. I have 3 y's here, 5 y's here, so it's always the greatest number of times that you see it. So I want to have 5 y's in my LCD. I have 1 z here, I have no z's here, but because it's the greatest number of times, you need to have 1 z here. Looking at another one, again, you really need to treat x minus 3 as a group and x plus 3 as a group. So they're treated as their own thing. So the first one has an x minus 3. The second one doesn't have any x minus 3's. But because you see x minus 3 once there, you need an x minus 3 in your LCD. The first one doesn't have any x plus 3's. The second one has one x plus 3. So you need to have an x plus 3 in your LCD. And then with this one right here, it has one x minus 3. This one has one x minus 3. So because I only see x minus 3 once in either one, so I mean I see it twice here, but it's only in each denominator once. You want it once in your LCD. This one has an x plus 2. This one doesn't have any x plus 2. But because you see it once in that LCD, you need to have it in your LCD here. Same with the x plus 4. Okay, on the last one, this one has an x. This one doesn't have any x. This one has an x. So I see x, or the greatest number of times I see x in any one denominator is once. So I need to have an x there. This one has an x minus 3. This one has 2 x minus 3's. This one doesn't have any x minus 3's. So the greatest number of times that you see x minus 3 is twice. So you actually need it twice in your LCD. Okay, so let's look at number 5. And I'm going to put my own parentheses here. So I'm supposed to factor if I can, but I can't really factor either of my denominators. So let's talk about our LCD. This one has an x minus 3. This one doesn't have any x minus 3. But because I see it once here, I need to have an x minus 3 in my LCD. The first fraction doesn't have any x plus 2's, but the second fraction does have an x plus 2. So I need to have an x plus 2 in my LCD. So this is what I'm trying to build up both fractions to have. So now I need to multiply by what I need to get the LCD. Meaning that first fraction, it has an x minus 3, but it's missing an x plus 2. So I want to multiply by an x plus 2 here. But to keep this legal, you also need to multiply the top by x plus 2. The second fraction has an x plus 2, but it's missing an x minus 3. So I need to multiply by an x minus 3. But to keep this legal, you also need to multiply the top by an x minus 3. Okay, so I want to simplify this, and we actually distribute this number across the parentheses. So on the top, it's going to be 2x plus 4 over x plus 2, x minus 3, plus 7x minus 21 over x plus 2, x minus 3. And now that they have the same denominator, we can just copy that denominator over. And we want to combine like terms on top. So 2x plus 7x is 9x, and 4 plus a negative 21 is minus 17. Now before we declare this as our answer, we want to make sure that we can't simplify it anymore. So I can't factor the top, so I'm not going to be able to match it up with an x plus 2 or an x minus 3. So this is our final answer.